All right, so again, we are in chapter, that's not an 8. We are in chapter 8, section 2. Dang it, I did it again. What is my problem today? Chapter 8, section 1, we are going to add, we are going to subtract polynomials. All right, so the first thing we're going to do is talk about standard form. Which is why that's the first thing up there. So standard form is when we take a polynomial and we put it in descending order by degree. Okay? Now, standard form applies to all polynomials. However, my only concern as far as this class goes is when there is one variable. If there's more than one variable, I begin to care a whole lot less about standard form. Standard form, when there's more than one variable involved, starts to get a little bit wonky. So I am less concerned about standard form when there's more than one variable. But when there's one, it's in descending order by degree. So if we have that polynomial, yes? Say again? I do. So what is the term with the highest degree here? 4x cubed. And so 4x cubed is going to go first. So putting this in standard form would mean that I would have 4x cubed first. What is the term with the next highest degree? Negative 5x squared. Excellently done. Way to remember the negative part of that. And then the next term is 2x. It's positive, so positive 2x. And then last but not least is the 7, so plus 7. Nicely done. Whew! Tricky stuff, right? Yeah. All right. So, let's take and talk about the leading coefficient. Now, the term leading coefficient is a bit of a misnomer. It implies, of course, that it is the first term or the first coefficient. However, the leading coefficient has the following definition. It is the coefficient of the term with the highest degree. It is the coefficient of the term with the highest degree. Now, having said that, when it's in standard form, of course, the leading coefficient should be first, right? Because the term with the highest degree should be the first term when it's in standard form. But even when it's not in standard form, the leading coefficient will always be the same. It is the coefficient of the term with the highest degree, which in this case is 4, right? So whether it's in standard form, like right there, or whether it's in not standard form, the coefficient of the term with the highest degree. So in this case, it's 4. So far, so good? Okay. Let's talk about adding. So, bear in mind, in a problem like this, that the parentheses are telling me what? What are the parentheses telling me? Yeah. No. But I am glad that you said it, right? You sort of fell into my trap. Yeah. Not quite. Yeah.
That's like one.
Yes. So the parentheses here are telling me that this is one polynomial. That these terms go together and form one polynomial. And then I am adding a second polynomial. Okay? The reason it's not multiplication, which a lot of people assume, is because of this addition. Okay? The only time it's multiplication is if this addition symbol or subtraction symbol is not there. Now, I will say that come test time or quiz time, there will still be a whole bunch of you that will fail this section of the test. Because you multiply them together. Despite the fact that the directions will say, find the sum or difference, there will be at least 2 or 3 of you in every class that will still multiply those together. Don't be that person. Right? Don't be that person. Pay attention to the directions and pay attention to what's actually there. Right? With this addition in between the parentheses, it means to add. It does not mean to multiply in any way, shape, or form. Okay? All right, so let's do this. When I work a problem like this, there's 2 ways to play with these. I'm going to show you both. The first is the method that I tend to use. You are welcome to use either one. I don't care, or you can create your own. But what I tend to do is underline, circle, or otherwise make shapes around like terms, put them together, and then do the math. In our notes today, in this problem, we're going to kind of show as much work as possible. After this first problem, we'll start streamlining it and there'll be a little bit less work. But in this first problem, we're going to show all of the work. So, 2x squared. Does it have a like term? Yes, it does. What is it?
4x squared. Or negative 4x.
Negative 4x squared. Good. So, the 2x squared, which sits right here, has a like term back here with the negative 4x squared. And so, if I'm showing all of my work, then I would rewrite 2x squared minus 4x squared, which is what, by the way? Negative 2x squared. So then I can come right underneath of it and do that math. All right, what about 5x? Does it have a like term? Yes, what is it? 6x. And so the 5x and the 6x are like terms, which means that I have those 2 terms to write together. And 5x plus 6x will give me 11x. So I have positive 11x. All right, and then last but not least, the negative 7. Does it have a like term? Yes, it does, and it's the 3. All right, and so I have negative 7 and then plus 3. Negative 7 plus 3 is negative 4. Then I ask myself, is this in standard form? And the answer is yes, and so this is my final answer. Does that make sense? You just go through, find the like terms, and combine them the way they're written, with the signs included. Right? So far, so good? All right, so the alternate method for this is vertical addition or subtraction. I don't particularly like this method, but I have a feeling that there might be a couple of you that do. So I'm going to show it to you real quick. You never have to do it, right? If you don't like it, don't do it, okay? So vertical addition basically takes one of them, puts it in standard form. The first one is in standard form. And so we'd have 2x squared plus 5x, and then minus 7. And then underneath of it, we put the other one, again, in standard form, putting the negative 4x squared first, and then a positive 6x, and then a positive 3. And then it literally just adds the 2 together. And so when I add straight down, I get a negative 4 back here. I get a positive 11x here. And then I get a negative 2x squared here. That looks like a weird 4, doesn't it? So let's fix that. There we go. All right, so not bad. There's a reason I don't like this one, and we'll discover that when we get to the next problem. But some people I can see liking this. Other people, this just seems to be a little bit too much work for their taste. So, but it is a viable option. All right, let's try another one. Let's try this one. So this one will illustrate why I don't particularly care for the vertical method. We'll do that after I do the method I prefer. Yeah,
Is that a dy or a 4y?
that's a 4.
Okay.
There's not 2 variables in here. It's 4y. Sorry. Sloppy 4. I don't know if I can fix it on here. Maybe. Can I do white? Will it let me do white? No, white's not an option, is it? Okay. We won't fix it. Alright. Alright, has everybody got that copy down? Anybody need more time? Alright, so here we go. If I start this problem, I will start by looking at the 3y. Does the 3y have a like term? Yes, it does. What is it? The negative 4y. So again, I've got the box here and I've got the box here. This time I'm not going to go ahead and show all that work. You kind of get the idea from the previous problem. What is 3y minus 4y? Negative 1y, or just negative y. Then y cubed, does it have a like term? Yes, it does. What is it? The 2y cubed. So I've got y cubed here. I've got 2y cubed here. When I add those together, I get?
3y.
Correct. 3y to the third power. Then we have the negative 5. Does it have a like term? And it is 8. So I'm going to take this negative 5 and add that positive 8 and get a positive 3. And then you'll notice that in the second polynomial, there's a leftover term, right? Does it have a like term anywhere? No. So it doesn't change. It just stays positive 4y squared. Does that make sense? All right, is that in standard form? No. So what would this be in standard form? What goes first? The 3y cubed, then positive 4y squared, then negative y, and then positive 3. And there's my final answer. Make sense? Okay, now, if I do this in vertical fashion, we'll soon get an idea of why I don't particularly care for this method. Number one, you have to put it in standard form when you do vertical addition. So that first one, if I put it in standard form, I start with y to the third power. Now, notice that this first polynomial does not have a y squared term. But when I do vertical addition, every degree must have a place. There needs to be something in every degree spot. But this one doesn't have a y squared, so I have to put a placeholder. 0y squared. Okay, I need that placeholder sitting there. Right? Now I can continue putting it in standard form. So a positive 3y and then minus 5. The second one, when I put it in standard form, gives me 2y cubed. Now this one has a 4y squared. And then plus or minus 4y. And then plus 8. And now I can add straight down. And so we get a positive 3 here. We get a negative y here. We get a positive 4y squared here. And a 3y here. 3y cubed. So because of using this concept of a placeholder, there's a lot of people that don't really care for this particular method of adding and subtracting. Okay? Again, I don't really care what method you use as long as you use one. And use it consistently and correctly each time. So far, so good? Alright, let's do one more. Let's do this one. subtraction. What needs to happen here with the minus sign? Is there anything different that has to happen? Yeah. True, I will subtract. But there's an easier thing to do besides just think of this as subtraction. Yeah. Exactly. We're going to distribute that negative through the problem, right? So I'm going to take this negative and I'm going to multiply it times each thing on the second set of parentheses, okay? Now, you can think of it as subtraction, but I have a feeling that most of you would get lost if you simply were like, well, I have 3 minus 4x, and then, or 3 minus negative 5, right? Most of you aren't going to remember to make that a double negative. But if you distribute the negative and rewrite, most of you, I think, will do all right. So, when you distribute, I highly encourage you to rewrite. So, the first part remains the same, 3 minus 2x, and then plus 2x squared. And now we distribute that negative. I wind up with negative 4x. A negative, negative 5. Two negatives make a positive, and then minus 3x squared. And now you simply go through and do what we've been doing. The 3 has a like term with the positive 5, giving me a positive 8. The negative 2x has like terms with negative 4x, giving me negative 6x. And the positive 2x squared and the negative 3x squared give me negative x squared, which leaves me with a final answer after I put it in standard form of negative x squared minus 6x plus 8. Questions, quandaries, queries? Okay. There's your homework.